In this video, we're going to learn how to create realistic animations. Well, slightly more realistic. Now, you might recall in the last video, we learned how to make a square appear to move using Turtle graphics. Import turtle, import time, creating the screen where we're going to draw stuff. Setting the fill color. Let's have a look at black outline. I think we'll do green squares today. Turning off the tracer to speed up the drawing. And the for loop we showed you in the previous video. If you haven't watched the previous videos or you're new to programming, I recommend you watch this playlist from the start and importantly try the code out for yourself. Software development is learnt by doing, not by just watching videos. We're going to use a for loop, which we demonstrated in the previous video. Screen.pen up, pen up, pen up, I think, yep. Pen up tells it not to draw anything. Whatever you do next, don't draw it. Screen.forward 3. Screen.pen down says we now want to draw stuff. Begin fill says that we want to draw a filled shape. And now we draw our square. (90 degrees) is a right angle. And the four sides of the square. Update tells us we want to update, and now that we've drawn, actually we need to do screen.endfill. Update tells us we now want to show what we've just drawn. Time.sleep, 0.1 seconds. And screen.clear. And hopefully if I've done it right, we now have a moving square. So what actually happened there is we did the animation on the screen exactly the way you would do an animation using a cartoon. This piece of code here in the for loop executed the commands inside the loop 50 times and did so very quickly. These commands executed. This is the command pen up tells this bit here moves the pen over slightly so that our square appears to move forward 3 units every time this piece of code is executed. This part here drew our square. So begin a filled shape, which was the shape of the square filled with green. Draw the sides of the square, and then end fill tells it we now want to fill. Update tells us we want to write whatever we've just drawn to the screen. And sleep gives us long enough to actually see the image before the screen is cleared, ready to draw the next one. Now, one issue with this is it doesn't look, it's just moving. I mean, it doesn't look very realistic. Oops, forgot to do pen up. Let's just do screen.clear again. Now, how do we make it look a little bit more realistic? Well, for one thing, if you drop something or push something, it changes speed. At the moment, the speed stays the same. In the real world, the speed increases by a linear amount every time, especially, well, for falling objects anyway, the speed increases. For objects that you push, like a shopping trolley, the speed decreases. So how can we make that happen in this code? Well, one way we can do this is to use a variable in place of our movement. So the difference between variables and just putting a number in is you can change the value of a variable each time. So let's make our square accelerate. Instead of just moving at the same pace, we'll make it move faster over time. So we're going to do speed equals 3. So initially the speed will be exactly the same as it was in our original version. But we're going to increase speed every time the for loop changes. Every time the for loop executes this code. And the way we do that is we go for frame in range 50, screen dot pen up, screen dot forward, speed. So instead of just directly saying 3, we're putting the word speed in there, which is currently set to the value 3. Now the reason why we do this is we can now change the value of speed. So next time the for loop runs, the speed will be different. And since we want speed to increase each time, we'll say speed equals speed plus 1. That means the first time round speed will be 3 and the pen will move 3, but the next time round speed will be 4 because it'll be 3 plus 1 equals 4. And the rest of it stays the same. Oops, bad. Start again. have I got enough forwards and rights? So one side, two sides, three sides, four sides of the square. Screen.endfill, update, tell it to write everything to the screen. Time.sleep for 0.1 seconds, enough time to appreciate what we've just seen. And then screen.clear, see how that looks. You can see the square appears to accelerate as it goes. Maybe that was slightly too fast an acceleration, so we'll edit it slightly. Instead of saying speed plus 0.1, we'll say speed plus 0. Or speed plus 1. We'll say speed plus 0.2. Let's see what that does. Oh, except first we have to bring the pen back onto the screen. So screen.home. Oops, update. Cool. Okay, let's do it with a slightly slower acceleration. I'm pushing the up arrow to get back to the previous command. Saves a little bit of time. And we've told it that we want speed to only increase by 0.2 this time. So a slightly gentler acceleration. Or not. Oh, of course. The reason why that happened is because we never set speed back to its original value. So speed equals 3. Screen.home, bring the pen back to the middle of the screen. Update. And let's see what happens with our gentler acceleration. Pushing the up arrow to get back to the previous command. You can see there it's accelerating, but a bit more gently than before. Okay, what else can we do? Well, why don't we make it bounce? So bouncing's interesting, because when something bounces, it changes direction. So when it starts falling, so if you imagine dropping a ball, the ball initially falls fairly slowly, moves quicker and quicker until it hits the ground, bounces up with a great deal of force, and then slowly slows down as it reaches the top of its bounce before starting to fall again. So we can simulate this with a very similar command to what we've just done. So we'll do screen.home. Screen.clear. Update. Now bouncing, of course, we want the ball to move downwards. So the way we do that is before we run any of this code, we have to change the direction so that when it moves forward, it'll actually move down. So we can do that by saying speed equals 0. We'll start from 0 this time. Screen.write 90. Update. Oops. Trying to get the spelling right. Notice how the arrow is now pointing downwards. And we'll execute our command here. Pushing the up arrow. And this time, speed is set to 0. So it'll start quite slowly and it'll move down. Let's see what happens. So it starts slowly and then it moves down quicker and quicker. Okay, that looks pretty good. So if we start at the top there, it'll get down pretty much to the bottom of the screen. We can pretend that's our floor. And then it stops. So we obviously have to do something to reverse this command to make it seem to bounce all the way to the top. So the way we can do that is by, instead of adding speed, we can subtract speed. So first of all, we have to tell the arrow, we have to rotate 180 degrees to tell the pointer here to point upwards instead of down. So screen dot right 180. See the arrows now pointing up. 180 is a full reverse, so going back the way you came. And we'll push up arrow now to bring back the code we just executed. But this time, instead of the code we just executed, instead of plus, we're going to say minus, because it's now at the bottom of its bounce and we want it to slow down as it reaches the top of its bounce. Let's see what that does. Cool. So that kind of worked, except we did the bounce in two halves. So how do we put the two halves together at once and make it keep bouncing? For that, we'll use another for loop. So for starters, dot right 180, we want it to start by bouncing downwards. Now we're going to use two for loops, one inside another, for bounce in range. Let's make it bounce 5 times. I'm going to have to type all this again, unfortunately. So this is the down part of the bounce. Oh, wait a minute. Okay, let's try that again. I forgot something. We've got to set speed to 0. Let's type that bounce in. Let's start again. For bounce in range 5. For frame in range 50. Pen up so that we can move the pen without drawing. Screen top forward speed. Speed equals, make it accelerate as it moves downwards, because at the moment the arrow is pointing downwards, so it's going to move downwards initially. Now we want to draw. Begin drawing a filled shape. Begin fill, yep. Drawing the square again. Four sides of the square, forward, 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 forward. Okay, I got that bit right. Screen dot end fill. Comment. Update to tell the system we now want to see the shape we just drew. Time dot sleep 0.1. Clear screen. Now we have to hit the backspace or delete button to tell it we now want to do another loop. We want to exit this loop, but we're still inside the outer bounce loop. So one backspace. Now, if you imagine what's happening, at the end of this, the square will be all the way down to the bottom, but the pen's still pointing downwards, because this is where we have to do the rotate, so to make the pen point upwards. 180, a full reverse. And now we do the same, this bit again, the 4 frame in range, except this time we're slowing down the speed because we want the ball to appear to slow down as it reaches the top of its bounce, or the square in this case. So exactly the same as this, except speed is -0.2 instead of +0.2. So screen dot pen up. Oops, -0.2. So slowing down as it reaches the top of its bounce. We're drawing a filled shape, a filled square. Four sides of a square. One, two, three, four. Yep. Okay. Update. Update tells this turtle in Python to draw what we just told it to draw. Time.sleep 0.1. Screen dot clear. Now there's one more command we need to put in here. Just as it reverse direction here, to start rising again after bouncing, we need it to reverse direction a final time so that it can start falling again. So if you recall, we're going to make it bounce 5 times. So screen dot right 180. Now hopefully if I've done this right, we're going to have a bouncing square. Return twice. So far so good. Ah, silly me. Never mind. Okay. Okay, sort of bouncing. Yeah, close enough. Would have been nice if it was bouncing up and down in the same spot. Yeah, we can fix that. So, do you think you can fix the bounce? What do you think's happening? Well, what's happening is when it bounces upwards, it's drawing from the current location of the pen, which isn't quite the way we want it. Okay, we'll do it in this video. See how we go. So let's go back to our bounce code. Now, make this a little bit larger so we can see all the code. Roll as much as we can. So there's our bounce 5. So this bit here was almost right, but we have to move it over. So when it went right, when it went right 180 and pointed upwards, it worked, but it was drawing the pen. It was drawing the square one square over, so we need to bring it back again. So how do we do that? Well, it's pointing down at the moment, so we need to make it move right 90. Which will actually make it point left because of the because from down perspective, turning right will make it point left. Forward. 50. And that'll bring it to pointing straight up. And similarly, at the end of this one, instead of going right 180, it's pointing up, we'll go right 90. Screen dot forward 50. Okay. Let's see where that gets us. Much better. It's bouncing in one place now. There's a little bit of a glitch at the bottom there where it's drawing a line. It shouldn't, just for a moment. Obviously you're bouncing this square on the... Oh, okay. So still not perfect, but certainly improved. And that's the nature of programming. Try it out, do things in small steps, and if it isn't quite right, go back and have a think about it and try to see what you've done. I think that's enough excitement for this video. I hope you enjoyed it. If you've come to this video first and it all looks a bit complicated, I recommend you go back to the start of the series, installing Python, which will take you from the very start. Let me know in comments if I moved a bit too quickly in this video. Then I'm happy to do some additional videos or answer questions. It's really important you try this stuff yourself. All of this code, you learn coding by doing. Videos can just help provide a few ideas and answer a few questions. Thank you very much for watching.